Today we're on page 27 of our note guide and we're looking at 2.1. We're adding and subtracting polynomials. Now polynomials, poly means many. Many terms is what we're looking at here. If I have a monomial, that is just one term. It could be a term, could be a number, a variable, or a product of variables and numbers together. The degree is the sum of the exponents of the variables. So let's go ahead and look at some examples of monomials. One example of a monomial would be 14x. 14x all by itself is a monomial because it's one term. Another example would be 3xy. All three of those are being multiplied together, but on its own, it's a monomial. The number 4 could also be considered a monomial because it's just one thing by itself. If we put pluses and minuses in here, suddenly this becomes a polynomial where we have multiple terms put together. Now the degree of each of these is you just take the sum of the exponents of the variables. So for x, the exponent of x is a 1. So the degree of 14x would be just 1. If I have 3xy, x has a 1 and y has a 1. So when I combine those together, it gives me 2. So the degree of that second term would be 2. The degree of the last term, if there's no variables, the degree is just going to be 0. A polynomial is a monomial or a sum of monomials. So if we take one and we combine them, that can give us more terms. So the terms with the same variable raised to the same power are called like terms. They have to be exactly the same to be like terms. A polynomial with two terms is considered a binomial. Bi means two. Think of a bicycle. A bicycle has two wheels, so a polynomial with two terms is a binomial. A polynomial with three terms is a trinomial. Or think of like tricycle. Tricycle has three wheels, so three terms is a trinomial. The degree of the polynomial is the greatest degree of its terms. So you look at each of the individual terms and you find the one that is the highest, and that will be the degree of the polynomial. A polynomial is in standard form when the exponents of the terms decrease from left to right. You always want to put the highest power first, and as you go down, they go on the right. So left to right, the left is the highest, the right is the lowest. The number in front of the first term is going to be considered the leading coefficient. So on this example, we have the leading coefficient is a 2. The degree is the highest power. That 3, x to the third, would be the highest power there. So the degree would be 3. The leading coefficient would be 2. The constant term is the number that's all by itself. So the 12 would be the constant term here. Keep in mind that the leading coefficient is only the first term if it's written in standard form. Let's look at number 1. We're going to write this polynomial in standard form. We're going to identify the degree and the leading coefficient of the polynomial. Now, this number 1 is not in the right order. So when I put it in standard form, we need to have the highest power first and the lowest power last. So if you look at number 1, we have 3x squared. 3x squared would be the highest power because it has x to the second power. That 2 is the highest number there. So that's what we're going to write first. The next term we're going to write is our x because it has x to the first power. So we're going to put that next, and then the 5 is on its own at the end. Next, we want to take and find the degree. The degree is going to be 2. That is the highest power of this polynomial. The leading coefficient is 3. The number in front, when we write it in standard form, is a 3. It's that front number. And then the number of terms would be 3. So this would be a trinomial. Number 2, we have the square root of 5y. This has one term, so it is a monomial. It's already in standard form. You can't rearrange one term. One term is just the way it is. It's not going to change at all. The degree is going to be 1. We don't have a power by that 1, but we always have a 1 if it doesn't show us the number. It's the so that degree is the highest power. The highest power we have is 1 because it's the only one we have. The leading coefficient is the number in front of the variable. Well, this one happens to be the square root of 5 because the square root of 5 is in front of the y. Looking at number 3, we have two terms. These two terms need to be written in standard form. We want to write the x to the 8th first because that is a higher power than x to the 5th. So if I have two terms, think of a bicycle. So it's a binomial like a bicycle. There's two terms, 2 wheels on a bicycle, 2 terms is a binomial. The degree would be the highest power. The highest power here is 8. Then the leading coefficient is the number in front when you write it in standard form. So this leading coefficient is 6. Now look at how we wrote it above. The 6 is second, but it's still the leading coefficient because it's by the highest power. So looking at number 4, we want to put it in the right order. The highest power goes first. That negative y to the 4th is going to go first. Then the 3y squared is second. The 6 doesn't have an exponent or a variable by it. So the degree of that would just be 0. That's the lowest. There's 3 terms. 3 wheels on a bike is a tricycle. So this is a trinomial. The next thing we're going to look at is the degree. The degree of this is going to be 4 because the highest power is a 4 by the y. Now, we're going to write our leading coefficient. There's not a number, we just have a negative there. But remember, if there's not a number, it's always a 1. So that leading coefficient is going to be that negative 1. Looking at number 5, we have 7xy. There is one term, so it is a monomial. Mono means one, monomial. Then we're going to look at the degree. Now we have two variables here. We have x squared and y to the 1st. We're going to add those exponents together to give us 3. So the degree of 7x squared y would be 3. The leading coefficient is the number in front of the highest power term. Well, since there's only one, it's just the 7th. That's all that we have to use. Looking at number 5 here, we are going to add the polynomials. Now, you can only add things together if they are like terms. So if I take 5 plus 4, I get 9. 2 minus 1 is 1, so I have 1x. And x squared plus 3x gives us 4x squared. You can only combine the things that are the same. So our answer would be 4x squared plus x. It's like plus 1x, but we don't need to write the 1 there. And plus 9. Looking at 6, we're going to add only the things that are the same. Negative 7 plus 5 is negative 2. There's nothing to go with the x, so we're just going to keep it by itself as plus x. We have negative 2x squared is the only thing there, but we have 3x cubed and 4x cubed. They combine together to be 7x cubed. Going over to 7, we want to combine the things that are the same. We have 10x squared plus 2x squared gives us 12x squared. Now let's combine the x's, 3x and just a plain x. Remember that x by itself, it's like a 1 in front of the x. 3x plus x gives us 4x. Negative 10 plus 9 gives us a negative 1. So we write that at the end there. Okay, looking at 8, we want to combine the things that are the same. Look at this 5x cubed. That's the highest power, but there are no other x cubes anywhere. So we're going to just write the x cubes. Next come the x squareds. 2x squared plus 6x squared is 8x squared. The negative 7x is all alone, so we just write that down. But we can combine the numbers that are negative 5 and positive 3. When we combine those, we get a negative 2. Looking at number 9, we want to combine the things that are the same. We want the highest power first, which is 4x cubed. That's the only x cubed we have, so it stays by itself. Next, we write our x squareds. 3x squared minus 7x squared gives us negative 4x squared. Then we combine our x's together. Remember, there's a 1 in front of it if it doesn't have a number. 1x plus 5x is 6x. And then we have a minus 6 off by itself at the end. Now, we can do this even if it's not whole numbers. We can add decimals together. 3.7n squared plus 4.3n squared. And I'm just over here, I'm going to just write these together and we're just going to add them by hand. Remember, we keep the decimal in the same place. 7 plus 3 is 10, carry the 1. We have 8.0, which is just 8. We have 8n squared. Here, the next one, we have negative 8n minus 2.9n. When we combine those together, they're both negative. So we're going to just add the two numbers together, which gives us negative 10.9. We keep that negative, the sign the same. Add them, we get negative 10.9. So our next term is going to be negative 10.9n. We combine 2.5 and 1.6. We have 6 plus 5 is 11. We carry the 1. 2 plus 1 plus 1 is 4.1 at the end. On number 11, we're subtracting the polynomials. Now, I want to make sure I take that negative and distribute it to everything in that bottom half. We're subtracting all three of those. And what that looks like is we just change the sign. 5 minus 3 is 2. 2 minus 3 is negative 1x, which is just negative x. And 3x squared minus 2x squared gives us 1x squared, which is just x squared. Looking at number 12, remember we have that negative. We're subtracting all of the bottom. So that negative distributes to all of them, except on the negative 2, a negative 2 becomes a positive 2. So 6 plus 2 is 8. The negative 3x is all alone. It doesn't have any common terms. We have negative 5x squared minus 6x squared is negative 11x squared. And 3x cubed minus 4x cubed is negative x cubed. On number 13, we have them written horizontally, but that negative still goes to all three pieces of the second term. Negative 2x squared minus 2x minus 8. So we have 11x squared minus 2x squared. That gives us 9x squared. 3x minus 2x gives us 1x. And we don't need to write the 1, we just write plus x. 1 minus 8 gives us a negative 7. On 14, we're subtracting again. We need to make sure that negative goes to each piece of the second half of the polynomial. So negative 6x squared, that negative times a negative is a positive 2x, and negative times a positive is a minus 7. So we have 16x squared minus 6x squared gives us 10x squared. 8x plus 2x gives us 10x. And negative 9 minus 7 gives us negative 16. On number 15, we're going to again take that negative and distribute it through. negative 3x squared. We have a negative 4x, and a negative times a negative 5 gives us a positive 5. Looking here, I have a 4x cubed. Now there are no other x cubes in the whole expression, so we're just going to put 4x cubed. Now we want to find all the x squareds and put them together. There's a negative 2x squared and a negative 3x squared. Together that is a negative 5x squared. Then we have the negative 4x. There's no other x's to put it with, so it is by itself. And then 5 plus 5 gives us 10. And that's all we do for 15. Looking at number 16, we're going to take the negative and distribute it through the second half of the expression. We have plus 7y squared plus 5y and minus 11. We just change all the signs when we distribute that negative through. We have a 4y cubed. That there are no other y cubes, so we put that one by itself. Negative 9y squared plus 7y squared gives us negative 2y squared. We combine the y's to be 3y plus 5y, which gives us 8y. And then we have that negative 11 all by itself at the end.